Hello everyone. So our today's topic is on K-map or Karnaugh map. Okay, so why actually we need Karnaugh map? So far when we have simplified a Boolean function, okay, whenever we have simplified a Boolean function, we have used the algebraic process, right? The Boolean algebra and their properties we have used. Okay, and sometimes it's a bit difficult to find out the most simplified form in that way, or sometimes it takes time to find out the most simplified way. Okay, but using this K-map, okay, we can find out the most simplified equation of any Boolean function very easily. Now for understanding K-map, okay, we have to understand the mean terms as well. Okay, so last class you have learned about mean terms, okay, and you have learned that we represent mean terms with small m, right? So let's see a K-map for three variables. Okay, so suppose we have three variables. So three variables K-map. Suppose we have three variables A, B, and C, or any three variables. It can be X, Y, Z as well. Okay. So if we if we have three variables, okay, then how many combinations we can have? We can have 8 combinations, right? And how many mean terms we can have from three variables? We can have also 8 different mean terms, right? So from mean term number 0 to mean term number 7. Now for three variables K-map, okay, if we want to design it, so the structure would be like this, and there would be 8 cells. So there would be 8 different cells, okay, and each cells will represent a mean term. Okay, so mean term number 0 will come here, mean term number 1 will come here. Now mean term number 2 will go there, mean term number 3 will be here, then M4 here, M5 will be here, M6 will be here, and M7 will be here. Okay. Now why mean term number 2 is here and why mean term number 3 is here, or why mean term number 6 is here and mean term number 7 is here? Now if we want to understand that, then we have to put the combinations for respective mean terms. Now if we consider M0 comes from what? 0, 0, 0, right? M1 comes from 0, 0, 1, 2 is 0, 1, 0, 3 is 0, 1, 1, right? 4 is 1, 0, 0, 5 is 1, 0, 1, 6 is 1, 1, 0, and 7 is 1, 1, 1, right? Now if we look here carefully, okay, if we look here carefully, that every adjacent cell, okay, every adjacent cells will have only one bit difference. Okay, so suppose any two adjacent cells, suppose this one and this one, okay, how many bit differs? So here is 0, here is also 0, here is 1, here is also 1. The last bit is different. This is 0 and this is 1, right? So only one bit difference. Okay, or any two, suppose this one and this one, okay, then the last two bits are same, the first bit is not same. Okay, so these two are also adjacent, or these two are also adjacent. So any two adjacent cell will have only one bit difference. Okay, any two, so suppose this one and this one, the last bit is different. Okay, so any two adjacent cell, take this one and this one, okay, and the first bit is different. Okay, so any two adjacent cell will have only one bit difference. Now to maintain that thing, okay, to maintain that thing, our M3 comes here and M2 goes there. Okay, for the same reason our M7 comes here and M6 goes there, to maintain that thing, that any two adjacent cells will have only one bit difference. Okay, so now this is one thing. Another thing is, if we think in an opposite way, okay, that suppose if there are one bit difference, okay, then those cells are adjacents. Okay, now this one and this one has one bit difference, so yeah, they are adjacent. Okay, or this one and this one are, this one have one bit difference, so they are also adjacent. But if we think this way, suppose this one and this one, okay, are they adjacent? They don't have one bit difference, right? They have more than one bit difference. So this one and this one are not adjacent, or this one and this one are not adjacent, or this one and this one are not adjacent. Okay, so if it goes this way diagonally, then we cannot say they are adjacent. They are not adjacent. This one and this one is adjacent, or this one or this one and are adjacent, or this one and this one are adjacent. Okay, but diagonally they are not adjacent cell. Second thing is, if we think about this one and this last one, okay, there is only one bit difference. See, this one and this one, only the middle bit is different. So we can say that this one is adjacent to this one, and also this one and this one has only one bit difference. Okay, so this one and this one are also adjacent. So it's like a round circle, right? So you can think like this first part is somehow connected with the last part as well. Okay, so it's also like a circle. Okay, so this one is also adjacent with this one, and this one is also adjacent with this one. Okay, so that's how so that's why this this M2 is here and M3 is here. Okay, so that it can maintain this kind of one bit adjacent thing. Okay, now another thing is, if we draw it little bit this way, and if we write all the min terms, okay, so can you write down all the min terms for ABC? For ABC, can you write down all the respective min terms? So what should be M0? M0 is A prime, B prime, C prime. Okay, M1 is what? A prime, B prime, C. Okay, so can you write it down? Just pause 1 minute and write it down. Okay, write it down, all of them. Okay, just check that you know how to write down the min terms or not. Okay, write it down. Okay, so hopefully you know all the min terms. So M2 is 0 1 0, right? So A prime, B, C prime. M3 is 0 1 1, so A prime, B, C. A, B prime, C prime. This one is A, B prime, C. This one is, oh sorry, let's come here, A, B, C prime, and this one is A, B, C. Okay, so we have written down all the respective min terms. Okay, now if we look at this K map, okay, and if I ask you, where are all the A's? Okay, where are all the A's? A's, not the A primes, A's. So where are all the A's? So you see in the last row all the A are there, right? All the A's are there in the last row. So you can consider that this last row, okay, this is for A prime. This is for A prime. So where are all the B? Figure it out. Where are all the B? So B are here, 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 and here, right? So we can write down this portion as B. Okay. Now where are all the C? So this, right? And the middle two column is containing all the C. So we can say these two column are for C. Okay. Now if this last row is for A, then obviously this first row is for A prime, right? So this first row would be for A prime. Okay. If these two columns are for B, then obviously these two columns will be for B prime, right? So these two columns will be considered as B prime. And if these two columns are for C, okay, then obviously this one and this one, these two columns are for C prime. Okay. So this last row is for A and the first row is for A prime. These two columns are for B and these two columns are for B prime. This middle two column are for C. So this first column and the last column are for C prime. Okay. So we have to remember all these things. Okay, that where is our A, where is our A prime, where is our B, where is our B prime, where is our C, and where is our C prime. We have to keep this thing in mind. Okay, so now let's see an example. Okay, let's see an example or a problem. So suppose there is a Boolean function given. Okay, so if of A, B, C is given, which is given as a sum of min-term form. Okay, sum of min-terms form. So suppose just a random min-term, sum of min-terms. Suppose this is given. Okay, this Boolean function is given, and we have to find out the simplified equation for f. The simplified equation for f using K-map. Okay. Now what does this equation mean actually? This is mean of sum of min-terms, right? So if we write down the equation, okay, basically we don't need to write down the equation, just to show you that what does this equation mean. If we write down this equation, then it would be, this is min-term number 2, right? Min-term number 2 is A prime B C prime plus min-term number 3 is A prime B C, 5 is A B prime C, 6 is A B C prime, and 7 is A B C. Or suppose this equation is given. Okay, so writing it this way or writing it this way is exactly same. Okay, so suppose this equation or this equation is given, and you have to find out the most simplified form of that equation. Okay, so let's do it using this K-map. Okay, so it's a 3 variable K-map, so we have to draw it this way. And we have to put the min terms. Okay, so the min terms we have, for that we will put a 1 and the other places will be filled up with 0. So min term number 2 is where? This is m0, m1, m2 is here, right? If you remember this table, right? So min term number 2 is here, so we put a 1 here. Main term number 3 is here, so we put a 1 here. 4 is not there, then 5 is there, so 5 is here, and 6 comes here, right, and 7 comes here. Okay, so we put this place by 1 and the rest of the places would be zeros. Okay, and now hopefully you remember that which one was A. This part was A, right? So this was A. Which part was B? This last two column was B, right? So we write it B, and the middle two column was C, right? So we write it C. Okay, so obviously this part would be for A prime, this part would be for B prime, and this two part was for C prime, right? Okay, now we got the main terms, okay, according to our question or according to our function. Okay, now our next task is we have to make some groups. Okay, now how to make some groups, and for that reason, okay, we have to learn some rules. Okay, so let's write down some rules here. Okay, that we have to follow some rules. Okay, so rules. So rule number one is that we have to create some groups. Okay, we have to create some groups of adjacent one. Okay, so have to create some groups of adjacent ones, one or ones. Okay, and there can be 2 to the power k number of ones in a group. Okay, now what does it mean? Okay, that means we can make a group of 2 to the power k number of ones. So 2 to the power 0 is 1, right? 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. So we can make group of ones, but only either of 1 1 or 2 ones or 4 ones or 8 ones. Okay, so we can create the groups in this way. Either there would be only 1 1, that can be a group, or there would be 2 ones, that can be a group, or there can be 4 ones, that can be a group, or there can be 8 ones, that can be a group. Okay, so 3 1 cannot make a group, or say 6 1 cannot make a group. Okay, there has to be 2 to the power k number of ones in a group. Okay, so that is rule number 1, that we will create some groups of adjacent ones. Okay, and the ones has to be adjacent. Okay, suppose 1 1 is here and another one is 1 here, so they cannot make a group because they are not adjacent. Okay, so it has to be some adjacent one, and there can be either 1 1 or 2 1 or 4 1 or 8 1. Okay, so that is rule number 1. Okay, now rule number 2 is, let's write down rule number 2. Rule number 2 will be, we will create less possible number of groups. So our task is we have to cover all the ones, okay, by making groups. Okay, we will cover all the ones by making groups, but we will try to create least possible number of groups. So if we can cover all the ones, suppose by 2 groups, okay, or if it is also possible to cover all the ones by making 3 groups, then obviously we will try to make 2 groups. Okay, so we will always try to cover all the ones by less number of groups. Okay, so this is rule number 2. Now rule number 3 is the last rule. Rule number 3 is every group will contain as many one or ones as it can. Okay, so every group will contain as many ones as it can, or the maximum possible number of one it will contain. Okay, that means suppose there is a group, we can make a group with 2 1, and suppose the same group, it's also possible that we can make a group with 4 ones, then obviously we make it a group of 4 ones. Okay, so we will always take maximum possible number of ones in a group. Okay, the group can be override to each other. Okay, the group can be overlap to each other, that's not a problem, but every group in every group we will try to put as many one as we can. Okay, so we'll try to make bigger groups. Okay, that's our goal. Okay, so first of all we have to make some groups, and every group will contain 2 to the power k number of ones. Okay, and the group will be designed by the adjacent ones. Okay, and we have to cover all the ones. Then we'll try to cover all the ones by using less number of groups. Okay, by creating less number of groups. And rule number 3 is every group will try to make it as bigger as we can make. Okay, or every group will contain as many ones as it can. Okay, so these are the 3 rules. Now let's come back to our example. Okay, to our problem. Okay, so here we can see these are the ones, right? Now according to rule number 1, we have to create some groups of adjacent ones. Okay, and we can create a group with 1 1 or 2 ones or 4 ones or 8 ones, right? Now if we think that, then these 2 1 can make a group, right? Or these 2 1 can make a group. Okay, or these 2 1 can make a group, or 1 1 can also make a group, or 4 1 can also make a group here. Okay, so these are the possible groups we can make. Okay, but we have to cover all the ones by making less number of by creating less number of groups. Okay, so if we create all the groups by single one, then there will be many groups, right? Or if we create these 2 as a 1 group and these 2 as a 1 group, these 2 as a 1 group, then there will be 3 group. Okay, but rule number 3 is also saying that every group must have to take maximum possible number of 1. Okay, now if we look here, that you can see this one is adjacent with this one, this one is adjacent with this one, this one is adjacent with this one, and this one is adjacent with this one. So this 4 can be inside a group easily. Okay, so we put this 4 inside a group. Okay, these 4 are adjacent to each other, right? Now there is a 1 here. Okay, now 1 1 can make a group, or 2 1 can make a group. Okay, or 4 1 can make a group, but this one's adjacent one is only this one, right? So either we can make a group with 1 1, or we can make a group with 2 1. Okay, but we will always try to take maximum possible ones in a group. So these 2 will create another group. Okay, the group can be overlapped, that's not a problem. Okay, like here the group has overlapped, so that's not a problem, but our goal is to create less number of groups, and every group will contain maximum possible number of 1. Okay, that is our goal. Okay, so we have successfully created these groups. Okay, so there are 2 groups. This is the bigger group with 4 1, and this is another group with 2 1. Okay, Now let's try to find out the simplified equation from it. Okay, now let's choose this group, this big group. Okay, now think like this big group. Okay, is it inside A? So where is A? A is only this portion, right? Only this portion. So this whole group is not inside A. Only a portion of this group is inside A, right? So we cannot take A. Okay, it has to be fully fitted under a letter. Okay, then we can take that letter. So is this group is inside A prime? No, A prime is only this part. So this whole group is not inside A prime. So this whole group is not inside A or not inside A prime. So we cannot take A or A prime. Okay. Now, is this group is inside B? Which is B? B is this portion, right? So obviously this whole group is inside B. So we can take B. Okay. Now, is this group is inside B prime? No, B prime is here, so obviously it's not inside B prime. Now, is this group is inside C? No, C is this part, so only one portion is inside C, but this portion is not inside C. Okay, so we cannot take C. Is this group inside C prime? C prime is this two part, right? So only one portion is inside C prime, but the other portion is not inside C prime. Okay, so we cannot take C or C prime. So only B we got from this big group. Okay, so this group is done now. Come to the next one, next group. Okay, so we put a plus. Okay, and now for this group. So is this group is inside A? Yeah, see, this is small group, this is A, right? So this is small group is inside A, right? So here is inside A, this group. Yeah, so this group is inside A. Is this group is inside B? B is this one. So this whole group is not inside B, only a portion, so we cannot take B. Okay, same for B prime. Okay, is this group is inside C? Yeah, see, this is the portion for C, and this whole group is inside this portion, so we can take also C. Okay, and obviously not for C prime. C prime is here. So this small group, this is inside our A and inside our C. Okay, so from this group we got AC. Okay, so from this group we got B, and from this group we got AC. Okay, so this is the simplified, this is the most simplified form of this equation. Okay, this is the most simplified form of this equation. If you try to simplify this one algebraically, it may take time, but eventually you will get this one. Okay, so it would not be very easy to find out from here to here algebraically, but using K-map we can easily find out the most simplified form of this thing. Okay, now here is another important thing that I have to tell you. Okay, so what's our rule number 2 was saying here? So hopefully you already got it, how we got the equation. Okay, now if we go to rule number 2, our rule number 2 was saying that we should create less number of groups. Okay, now why it is like that? So see, here is only 2 group, that's why we got 2 terms, right? Okay, so if we have created more groups, then more terms would be there. So that's why our goal is always to make less number of groups, so that there would be less number of terms. Okay, now in rule number 3, if you look carefully in rule number 3 is saying every group should contain maximum possible number of ones. Okay, or the group should be always bigger as it can be. Okay, like if it's possible to create a group with 2 1, and if it's possible to create a group with 4 1s, we must have to make a group with 4 1s. Okay, so why this is? So see this bigger group that was containing 4 1s, and from this group we got only one letter. Okay, and this is small group here was 2 1s, so from here we got 2 letter. Okay, that means the bigger the group is, your number of letter is less. Okay, so if you take 2 1s for a group, you are getting 2 letter, but if you are taking 4 1s as a group, you are getting only 1 letter. So that's why this goal is there, that we have to try always to make the bigger possible group. Okay, every group should contain maximum possible number of ones. Okay, so this was the rule number 3. So hopefully you got it, why rule number 2 and rule number 3 is like that, so that ultimately we got the most simplified form of an equation.